Yes, hello everybody. Macroeconomics. We are, yeah, looking at the system of the general targets in macroeconomic policy. And yesterday we talked in general about economic growth, and then we went on with the aim of price level stability, and this we will do in more detail today. Well, yesterday we already started with a general aim, and here we are, in some kind special situation, especially in Europe or in the European Monetary Union, since we have here, in what we understand by price level stability, an explicit target. So if we go to the European Central Bank, then we find there an explicit quantitative definition what is understood by price level stability, and this is when the inflation measured via the HICP is around symmetrically in the medium term at 2%. So this is the explicit target by the European Central Bank. And if we look at the actual inflation rates, which are right now 4, 5, 6% within the European Monetary Union, then we are a bit far away from this target. Okay, but then also we ask, if we ask how do we organize our society and our economy, then we said, well, in general, we want that the market is solving the general economic problem. Which goods and services should be produced and in which amounts should be produced our goods? And then, of course, well, in a free market process, there would be then, by the dependence between supply and demand, the equilibrium price anywhere. So why is it then in general, from a macroeconomic point of view, a good choice to have the aim that we have price level stability? And for this, we looked for reasons, and well, maybe the most important reason is that for a functioning market process, the price is the signal of scarcity of the good, which drives the process between demand and supply. And if in general these prices are very volatile, then there is much uncertainty in the market, and this process doesn't function very well anymore. So it doesn't mean price level stability that every single good should only change by 2%, but the price level as a whole. And how do we measure such a price level? This we will do in a minute. And of course, with high inflation rates, then one main function of money is not there anymore, that we want to store, so to speak, some of our income for future expenditures, and then the function that money can store the value over time would be anymore there. Also, if prices always change, then we have to make always new price declarations. These are classical transaction costs. And of course, in the credit process, which we need especially for our large investments, if there we have much uncertainty due to very volatile price levels in our economy, then it is also clear that this process doesn't function anymore very well, because you can imagine you giving out the money today and you will be, so to speak, repaid with money which is less worth than before. And this will then rise interest rates, and interest rates are the prices of a credit, and if the prices are higher, then you have less investments, and we need a specific level of investments in our economy. And this, of course, then also has an impact on the decision between consumption and savings, and especially these savings are needed for the investments. Okay, but now we want to go to the explicit measurement. Well, for this we will calculate, so to speak, an average of many prices of many goods we are consuming, and which goods will feed into this average price index. Well, there we look at one representative individual and the choice of this representative individual, which goods and services does this individual want to consume. This will be then in the basket of all single goods we will look at. And the calculation is then that we at first choose these single goods. This will be then, think of the circular flow where we looked at the sector of the private households, that we want to feed in there all relevant goods and services of these representative household. So in general, which goods feed into the private consumption. This is what we want to measure here. And then, of course, we have to weight these goods. Well, for example, look at yourself. Maybe you are drinking milk in general, then this would be one good. And also, I think you have a washing machine in your flat. So this is also a good you are consuming. But then you have to keep in mind a washing machine you are buying maybe every 5 years or 7 years. And a liter milk you are drinking every week or every 3 days or so. Well, and then you have to put these together. Maybe you also look at a time period what you are consuming within 1 year, and then, for example, you have to divide more or less the price of your washing machine by, I'm buying this only every 5 years, divided by 5, where while you are drinking within a year, I don't know, 100 liter milk. And from this, you come to different weights for the single goods. And these weights are coming from your general way of consumption. And again, you are looking at this representative household, and from this representative household, you then deduce these weights for every single good. Well, if you have then this weight, then you look at the explicit price of the good, and what you are doing then is that you sum up all the multiplication of weight times the price. So sum of weight times price. Well, and if you have this, this will be then the value of your basket. So you multiply all the determined prices with the chosen weights, and you're summing all this up. And of course, you have to take always the prices at the same time. So today you are going to the gas station. Today you are going into the supermarket, and then you just look up there the prices. And this is explicitly the way how the statistical office is doing it. So they take these prices every month. Well, and then similar as we did it for the GDP and calculating economic growth, we also take then this value of our basket, and we are setting then 1 year to 100. Well, and also as in the case when we calculated economic growth, we are mainly interested not in the value itself, but in the change of this value. And therefore, it doesn't matter if we set 1 year to 100, because again, we are only interested in the relative change. So at one base year, we set this index again to 100, and every movement in time afterwards we obtain then when we take the value of T1, T0 relatively and multiply this with 100. And in a minute we will do this, of course, also with an example. Well, and inflation is then nothing else than the change of this price index. So this would be then inflation equals CPI of t minus CPI of t minus 1 over CPI of t, or t minus 1, sorry. CPI of t, CPI of t minus 1 minus 1. And as we did it when we calculated average growth, this we later on also need when we calculate average inflation rates. This is then the so-called inflation factor. Yeah. And if we go then, for example, to the website of the European Statistical Office, Eurostat, then we find there just the definition of their so-called harmonized index of consumer prices. And this measure changes over time in the prices of consumer goods and services acquired by households. They give a comparable measure of inflation as they are calculated and called according to harmonized definitions. And this will be monthly taken. And as I already mentioned, this is then nothing else than the product of the weights times the prices. And I have also to give here that the sum of all weights has then to be 1 or 100%. Oops, there we are. Well, I hope that this is not broken. Let's see if it works. Yeah. So if you click on this, because you also have to keep in mind, these are here the weights of the representative household. But of course, these weights do not need to correspond with your private or individual weights. And here I found the page where you could then, for example, change the weights to your individual weights, and this would be maybe interesting for you that you put in your own choice. You know what you are paying for your flat, what you are paying every week in the supermarket, and so on. And then you can calculate, so to speak, your own personal inflation rate. And maybe you find then that this differs a little bit from the general inflation rate you are reading in the media. Yeah, then let's look at the actual weights we have here, and then you see especially the main category is just house, electricity, water, gas, so energy in general, and your cost of living in general. So this I already have written down. Inflation rate is then nothing else than the relative change of our consumer price index. And now, as I promised, we will do also one little example as we did it for the economic growth. Again, we will do it in a very simple way that we don't look here in this case at 100 or 1,000 single goods, but only at two goods, milk and butter. And now we have here now the price development of these two goods, and we know the weights. And this is a little bit different to the case of economic growth, because now, of course, we assume that these weights are constant over time. Well, I talked when we were dealing with economic growth, also that of course goods are changing over time in quality, and some goods are vanishing, other goods we invent other goods over time, and of course also our way of consumption will change over time. And for this also these weights are in general not constant over time, but well, every 10 years, we rethink about the weights and look at the average consumption in our household sector, and then these weights will be then also changed, as I mentioned it, every 5 or 10 years when the way of consumption has changed. Okay, but back to our example. Let's then now try to calculate at first the value of the basket, then the price index, and in the end the inflation rate. And I also wanted then from you the average inflation rate over time. Okay, so then this I will also do in Excel with you. Inflation. Well, this is already the solution. Let's take this out and So what do we have to do in order to obtain the value of our basket when we have these prices and the weights? Remember, the value of the basket is the weighted sum of all our prices. What do I have explicitly to do? Yep. Mhm. Yes, so 1 times O3 plus, yes, that's right. So this equals 1 times O3 plus O8 times O7. So we obtain 0.86, and this, of course, then we have to do for every year. So 0.86. The next one was 1.03 and 1.045. 1.03, 1.045. Well, price index we can set in the base year to 100. Let's take 2017. What is then the price index of 2018? Oops. 1 would be 1 times 0.3 plus 0.8 times 0.7 equals 0.86. If 0.86 is 100, what is then 1.03? Yep. Oh, I would doubt this. Oops. Another idea, also in the internet. Can also type it in the chat. Well, what we want to have is x to 100 equals 103 to 1086. And this you have to solve. For x, so we obtain x is 1.03 over 0.86 times 100, and this will be then equals over 86 times this 100 downward. Well, let's 119.77 and 10151. 119.77 and 121.51. So how do we obtain inflation? Well, inflation rate 2017 is hard to calculate if we do not know what is the price index in 2016. But inflation rate 2018. Relative change of our consumer price index. Any idea? Hmm? let's go back to our definition. So to speak, CPI today minus CPI yesterday over CPI yesterday. So what would it be? Hmm? Nobody? Yep. Yes, that's right. Because the numbers are that easy, we can directly write it down, and this would be then 119.77 minus 100 over 100 is 19.77%. And this was 119.77 in order to be complete. This we will also do here. So over 100, and now I take the inflation factor, and this would be 1.46%. Maybe I write this also down that you know that it is not only always with respect to 100, so this would be then 121.51 minus 119.77 over 119.77 equals 1.46%. Well, and the last one is, what is the average rate of inflation? So is it possible just to take 19.77 plus 1.46 and dividing by 2? If I pose this question like this, then we know that this is not the right answer, because this is then the same kind of problem we had when we wanted to calculate average growth. Yep. Yes, and which numbers do we have to calculate when we want to apply the geometric mean? So is it then the geometric mean of these two numbers, or? That's a good question. Well, for this, I mentioned just here the so-called inflation factor. But that you really see it, let's do it again. What we are looking for? We are looking for a number with which we want to twice multiply 100 in order to end up at 121.51. Well, and the mathematical formula for this is then that we seek 100 times 1 plus pi bar, our average inflation rate, and over 2 years, 2018, 2019. So, like the case when you are calculating interest over time and you are buying some investment with an interest rate of 5%, then every time you have remultiply with 1 plus 5%. So this is then 100 times 1 plus pi bar squared. And with this, we want to end up at the index of the year 2019. So 121.51. And this we have to solve now for our variable we are interested in. So this would then come to 121.51 over 100 equals 1 plus pi bar squared. In order to get rid of the square, we take the root, or we take the exponent 1/2. So 10151 over 100 up to 1/2 equals 1 plus pi bar, and then we have to subtract -1 from both sides. So we obtain 121 1/2 minus 1 is pi bar. Well, and where is now our geometric mean? For this, I write the left-hand side in a little bit other way, because we can rewrite this also as 121.51 over 119.77 times 119.77 over 100, and there we take then the root, -1 is pi bar. And these are again our inflation factors. This was 2018 and this was 2019. Just divided this number by this and this number by this. Well, and then this is nothing else than the geometric mean of the inflation factors. Well, and again, compare this to the arithmetic mean. So the geometric mean is x1 times x2 times x3 times xn up to the power of 1 over n. And the arithmetic mean looks very similar. We just replace the multiplication sign with a plus sign. So x1 plus x2 plus x3 plus xn, and divided by n means multiplying by 1 over n. So it looks very similar. And yeah, I think especially in economics, we are averaging quite often growth rates, and therefore you should know that to be mathematically exact, that you need then the geometric mean, and you more or less can keep in mind if your numbers for inflation or growth rates are less than 10%, then the difference between the outcome of the arithmetic mean and the geometric mean is almost the same. So then the arithmetic mean is a good approximation of the geometric mean. But if it's not the case, and just some month ago we had, for example, inflation rates of more than 10%, then you really have to use the geometric mean. But I want also to calculate it here. So then average inflation rate. For this we need the inflation factors. 2018, 2019, and this would be then 121 over 119, and oh, this is 2019, sorry, and this is then the other inflation factor, and average inflation rate is then the product of the two inflation factors up to the power of 1 over 2 minus 1. Or you have also directly a formula, and this is surprisingly geometric mean of these two numbers, minus 1, and fortunately we obtain here the same numbers. And we end up with 10.23%. Okay. So we will do also additional exercises on these calculation, growth rates, inflation, and yeah, in my opinion, it is quite important since these are more or less the maybe most important or most prominent macroeconomic indicators that you then know what it is and that in general you also know how it is calculated. Because also quite often we rely in economic policy on these quantitative numbers, and then you should know what you are talking about. Okay, but there are also other price indexes. So we had the consumer price index, and we already talked about the GDP deflator, and this is more or less then the price index for the whole economy. And here, see, this is the here we are focusing on the private consumption. And if you remember, when we talked about GDP, private consumption around 50 to 55% of total GDP, well, it is the largest component of GDP, but it is not total GDP. So these two prices will differ. And we can also say that, yeah, if the supply side goes into the wage negotiations, then in general they will look at the GDP deflator because this represents all goods and services we have produced in our economy. And then they can say, of course, when GDP deflator has risen by, let's say, 2 or 3%, then also the revenue of the firms has risen by 2 or 3%. And this you can then give back on your employees. And the discrepancy between these two price indices, there in a minute we will have a look at. Then, of course, we also calculate so-called export and import prices and look especially in our actual situations at the rise of energy prices. Then we see that from especially import prices, we more or less can then import inflation from outside. And this we had especially in the last month, in the last years. And then there is the so-called wholesale price index, so where the supermarkets are buying their goods. And of course, if we look at this wholesale trade, maybe somebody of you is working in the sector besides your studies, then we can say if this wholesale price index starts to rise, then later on we should not be surprised when also consumer prices will rise. So in this case, we can say that this wholesale price index is maybe some early indicator for the inflation rate in general. And actually, it is the case that the rise of wholesale prices went down in the last months. So maybe then we will also see that the consumer prices will come down in the next month. Okay, but let's have a look especially at the change of CPI and GDP deflator. Because what we already said, the supply side mainly looks in wage negotiations on GDP deflator. Because this represents the rise of all goods and services. Because this represents the change of the prices of all goods and services. Well, but the demand side, so this producers so in general private households mainly look in wage negotiations at the CPI because this represents the expenditure of private consumption. Well, and now interpret this. Here we had a phase that CPI inflation was larger than GDP deflator. And here we had a time period where GDP deflator inflation was larger than CPI, and in the actual situation it's changed again. So here again CPI inflation is larger than GDP deflation. Well, and now we can look at the process as wage and of wage negotiations in general, that in such a period, of course, the employees, they argue inflation is here of private consumption 2%. I want that my wage rises by 2%. Well, this seems reasonable when I say that I'm working as good as before. But also the argumentation of the supply side is reasonable. They say, well, in general, our revenues have risen only by 1%. I can give you only a wage rise of 1%. Otherwise, my costs, my labor costs will rise much more than my revenue, and then in the medium term, at least, I will have a problem as a company. So here, problems in wage negotiations since employees want a higher wage rise than producers want to give them. And in such a situation, we have, compared to this situation, less problems. In wage negotiations compared to this situation. And if we look at this more or less almost 10 years, then we find in Germany also that there were not very much problems in the general wage negotiation process between the supply side and the demand side. Well, and then now it changes again, and actually in this situation we see that these problems come back, because many people, especially with lower incomes, say, well, we have so much to spend on our for example, for our food, that I really need that the wages rises a little bit higher, and also some politicians argue in that direction. But you see, although we have also a high price development in the GDP deflator, it is almost 2 percentage points lower than the inflation due to the inflation measured by the consumer prices. Well, and then have a look also at a longer time series. Here, quite often we find the argumentation that in history all was better, everything was better. But if we look at the time before we have introduced the euro, then we see that average inflation rates were much higher than compared to the inflation rates, average inflation rates during the euro time. And also prices were much more volatile. So in this case, of course, we can criticize the euro, but if we make a description of the situation and compare the time before Europe and after before euro and after euro, then we have to admit that with the euro, the prices until now have to be much more stable during these times. But of course, in the actual situation, we see here also this dramatic increase of prices, but also we see during the both oil crisis, oops, in this time we had similar high inflation rates. And here also the time series with monthly data, and then you see here that in the actual situation we see that prices come slightly down, and we see if we again come down to our target of 2%. So this is our ECB target. So, and then I also want to show you that in some, so to speak, dramatic times, it could be the case that inflation in general, although it should represent this large basket with many, many goods, around 1,000 goods we feed in this basket, that this inflation rate can sometimes only be driven by very little goods, and especially if we look at energy prices just in the recent history. And there we see that last year we had a rise of almost 40% of energy prices. And so let's then try to calculate inflation if we assume that energy prices have risen compared to the former year by 40%, and we assume that all other prices will be constant. And we know that energy in general has a weight of roughly 10% of the whole index. So what we can do now is that at time t, CPI this would be 0.9, the weight of all other goods. So index of non-energy goods plus 0.1, the weight of the energy index of energy goods. And this as a starting point, since we are only interested in the change, we can set to 100. What would be then, or if we set this at 100, this is then be calculated by 0.9 times 100 plus 0.1 times 100. And now we change only the energy component by 140. Then we obtain CPI T plus 1 is 0.9 times 100. Since we do not want to look at a change of all other goods, we just want to calculate only the effect of the energy part plus 0.1 times, and if the energy component has risen by 40%, then I have to multiply with which number? Yep. Yes, 140. Well, and this is then 90, and this is 14, and so we end up by 104, and then we obtain inflation pi equals to index of CPI T plus 1, 104 minus our index of the former year, minus 100 over 100 is 4%. So, although the energy component is only 10%, the change in prices, in energy prices, will rise the whole index by 4%. Well, and if you think of the last year when we had almost 10% inflation rates, then we know since energy prices has risen by about 30, 40 or 50%, that almost half of the rise in inflation just comes from this single component. And this you also have to keep in mind when you interpret inflation rates in general. Is there maybe just a situation that some volatile goods have very high changes in prices? And then sometimes the total index is mainly driven only by one component. Yeah, then we have some time left because with this we want to end up with the topic of price level stability, and now we will come to the aim of high level employment. Well, what is then meant by high level employment? Oh, that in principle our aim will be to reach the state of full employment, but this does not mean that everybody has to work, but that every person who wants to have a job, so every willing person has a job. And look at our social system, social security system, and just on a descriptive way, then we see that we also get money and we also can apply for goods for a flat without working. Then, of course, it is not surprisingly that there will be also people which are not willing to work. So, in general, this is measured by the unemployment rate. In a minute, I give you also the definition, how it is defined in Germany and how it is defined in an international way. And yeah, well, since due to our social security system, in general, our aim would not be to have here 0% unemployment rate, but a little bit higher. And well, if you calculate 3 or 4%, there is a potential of roughly 45 million people in Germany who could in general work. So we would then talk in Germany about full employment when roughly 1 to 1.5 million people are still unemployed. Let's have also a look at the development of unemployment in Germany over the last 30 years. Then we see after reunification, we had this rise in unemployment, and then we had a really special situation in Germany that for almost 15 years we had a constant downturn in unemployment rate. And also have a look at these little kinks here. This is financial crisis. And this is Corona. And also these were very dramatic crises. Unemployment rose only a little bit, and later on we will also talk about this and what is the reason for this. And also we can state that, yeah, we had some kind of decoupling of the labor market from the general economic performance in Germany, because also during this time we had, for example, also the European debt crisis, and this was not only a totally prospering time, and still we had this general downturn in the unemployment rate. We will talk about this also. But let's see, how is unemployment defined? First of one is here. This is the German labor organization, the so-called Bundesagentur für Arbeit. And so we look at people in between 15 and 65 years, and it is written down in our social code, book 3, the so-called Soziales Gesetzbuch number 3. And who is then unemployed? Oh, why has that moved? I don't know. I didn't change anything. Actually, I don't know. So now it should work. So we look at people temporarily not at work and working less than 15 hours a week. And what is really important, on the former slide, I said who is willing to take a job. They have to seek an employment, and they have to take efforts in order to get a job, and they have to go to our labor institutions and together with them they have to be in the process of seeking a job. And the last one, also quite important, is, well, at least you have to go to the labor institution and you have to be registered. And there later on we will look also at the so-called hidden unemployment, because there are also quite a lot of people where we in general would say that they are unemployed, but they are just not registered. Well, but this is the special definition in Germany. In France, in the United States, in Great Britain, we will have other definitions. And for this, we have the so-called International Labour Organization. And in order to compare internationally different countries, then of course we also want to measure unemployment in the same way. And this definition differs a little bit. They look in an international focus on the people between 15 and 74, and somebody who really looks for a job now within 4 weeks, and he can start a job within 2 weeks. And what is now important in this statistic, it is not relevant if you are registered unemployed people or not. So sometimes these numbers are also taken via a telephone interview or so. So these numbers then, of course, do not have to correspond to the official labor market statistics. And yeah, in general, we cannot say which parameter is better, the national statistic or the international statistic. It always depends on oops, the question you are posing. So for international comparisons, then of course the ELO unemployment rate would be a good choice. For national economic policy questions. Well, then of course the registered unemployed people are the relevant one, because these people get the money of the social transfers. Yeah, then I have also monthly data for you since 1991, and yeah, maybe for the weekend or as a homework, you can think of why do we have this always repeating pattern here within the data of the monthly unemployment rate, because our next topic will be then that we look at different types of unemployment. And this we will do then next week. So thank you very much for today. And we see on Tuesday, I think. Yep. Again, also in this room during this semester.